Okay, Assalamualaikum class. So let's continue on the next part of the phasor, that is what we call differentiation and integration. So to convert from differentiation and integrate to the phasor, so if we have the time domain here, when you want to convert, it become v towards the angle, so need to be in the cosine form. And when you have the differentiation, you just need to add the complex number here, j omega v. But if we have integration, it need to be division, that is v over j omega. Okay, so let's recall back. What is the difference between sinusoid and phasors? So phasors is a ball V or ball I, current and voltage. Sinusoid is depend on time, right? VI, VT and IT. So VT is the instantaneous or time domain presentation, while V here is the frequency domain or phasor domain. This is both are time domain. So since this is a time domain, it is a time dependent, while V is not. Okay. So VT is always a real number, but your phasor is always a complex number, where you have what we call real and imaginary number. Okay. So let's try to solve this example 10. You are given a integral and differential equation. So this is the integral, this is a differential, and this is a sinusoid. First step, what you need to do, change the sinusoid to phasors or transform sinusoid to phasors. So here is actually, so what you have here is 50 angle 75 degree. Okay, so now slowly, because this is in a current, so when you want to change this one to the phasor, it becomes 4 bold capital I, 4I plus 8 is the constant. Now look at here, this is a differentiation. So when it differentiate, you change to phasor, it becomes 8I, the bold I, divide by j omega, minus 3. Now this is a differentiation, so it means multiply 3 j omega I. Okay. So now you have the denominator here, so you're going to eliminate this denominator. You multiply both by j, so it becomes 4I plus 8ji divide by. Okay, still remember last time j multiplied by j is always equal to minus 1. So this one become minus. And in this question, the omega here is equal to 2. So become minus 2 minus 3j 2i is equal to 50 angle 75. So let's simplify further. 4i. So it's not plus here. It is minus 4ji minus 6ji equal to 50, 75 degree. Take out the I. So this is phasor, right? Take out the I. 4 minus 10j is equal to 50 angle 75. And then finally you can get your I. You just divide 4 minus 10j. So this is a rectangular form. So you need to change to the polar form for you to divide. Okay, so by changing the rectangular form to the polar form, and then just use your calculator, you can get 4.642 angle 143.2 degree. Always leave your final answer to the sinusoid again. So it will become 4.642 cosine 2t plus 143.2. Okay, just now how you get W is equal to the angular frequency by looking at this equation. This is WT, right? So your angular frequency here is equal to 2. So that's why you substitute here is equal to 2. Okay, so this is how you solve the integral and differential equation. So I leave this to you. So if we make it, this is 2. This is differentiation, right? So 2j, the omega here is 5. 2j 5 V, okay, plus 5V plus 10 V over J 5 equal to 50 angle 30. Then try to solve by yourself. Multiply this one by J and J. J multiplied by J is equal to -1 and try to get this answer. Okay. Now let's see. Now we move to the circuit. So if you look at this circuit, it have a source. There is a AC, cosine 40 minus 15, and then you have a resistor, you have inductor, and you have capacitor. So can you solve this one in the time domain? Of course, yes, but the derivation may be sometimes very tedious, right? So is there any systematic methods to do this? The answer is yes, by using everything to transform all your elements, your resistor, your inductor, and your capacitor to the form of phasor. Okay. So now we are here, we already cover sinusoid, phasor, and impedance. So in the next video, you will see what is actually inductor, what is actually capacitor, and how you relate this one to the phasor form for you to solve this circuit like this. Okay, so that's all for this video. Assalamualaikum.